Okay, there was a question in terms of what Top Hat. Top Hat made the statement that that when you're drawing resonance structures of anions, there needs to be two arrows, and when there's a positive what we call carbocation, that there needs to be just one. And let me go back through using the same example that we used with the radical in an earlier question. Let me show you with a C- or a C+ what exactly that means. So I'm going to go back and write a 3-carbon structure here, and I'm going to put a double bond on the left side, and now I'm going to put a plus charge on the right hand side. And so this is called a carbocation, and drawing the resonance structure of this carbocation will mean that what we're going to do is we always move electrons towards a positive charge. And last time we used a single-headed arrow equals the movement of one electron. A full-blown arrow means the movement of 2 electrons. So in order to draw the resonance structure of this carbocation, what I would do is I would I'll take the 2 electrons in that bond, and I will move it over here to now form the center right carbon-carbon double bond. So both of those electrons are moving, which is why it's a full-headed arrow. And if I do that, I'm going to end up with the double bond now between the center carbon and the right-hand carbon. And now it's the left-hand carbon that has just 1, 2, 3 bonds. This carbon has lost an electron, and so now it has the positive 1 formal charge. So in moving that pair of electrons from the double bond going from the left to the right, the carbon on the left lost ownership of its electron, and so it becomes positively charged. And so when they say that this would require that a positive ion requires 1 arrow, that's what it means, because I'm just moving a single pair of electrons towards the positive charge to then write the resonance structure. So that's why we just have 1 arrow in this. Now, if I make this system an anion, starting with the same structure, only now making an anion. To make the anion, the carbon's going to always have a lone pair. So a carbon with 3 bonds and a lone pair always has a -1 formal charge. So this is called, if this was called a carbocation, then this is called a carbanion. And so with the carbanion, it says it requires the movement of two arrows, or 2 sets of electrons. And so here's how that would work. If I want to draw the resonance structure for this carbanion, I'm going to take this lone pair and I'm going to use it to form a carbon-carbon double bond. But if I do that, that carbon would have 10 electrons around it. It would break the octet rule. So as I give this lone pair to form the double bond, I got to move this lone pair out and give it to the left-handed carbon. Again, these are 2 full arrows. So the resonance structure would look like this. And so now the carbon with the 3 bonds and the lone pair would have the negative charge. So when you're drawing resonance structures for carbanions, because you're going to move a lone pair to form a multiple bond, and then you're going to move another lone pair out to a carbon to form the lone pair, it always requires 2 arrows in that process. instead of just one for the carbocation, or the 3 half arrows which we saw for the radical. So that's why they make those statements, is because simply we need to move those pairs. We need to move the pair of electrons. We need to move 2 pairs of electrons in order to form the other resonance structure, whereas if it's a carbocation, we just need to move 1 pair.